So today I'm going to go ahead and continue with some examples with logarithms. This time I'm going to focus on the natural log. The natural log, that's what I'm doing today. Yesterday with common logs and other logs. Today is just purely natural logs. So this is where I want to start with. Remember, the natural log of x is equivalent to a log base e of x. So anytime you see a log with a base e, it's going to be written as the natural log for short. All right. So this is what we present, but this is what it actually is. All right, so if we had to evaluate this problem, which is the natural log of 1 over e to the third power, how would we figure that one out? We'll use the same rule that we just talked about right there. This is going to be how we figure this out. So it's two things that I did here. Remember, this right here in the denominator can be moved into the numerator if you change the sign of the exponent. So now 1 over e to the third, when you basically get rid of the fraction form, is just e to the negative third. And remember, by definition, natural log is a logarithm with a base of e. So I made two changes to this one problem so that it looks like this. And remember, from here on out, it's going to be a circular motion. So e raised to the question mark is equivalent to e to the negative third. There's my conversion. Remember, we went from a log form to exponent form. If these two bases are the same, all you can do is set the exponents equal to each other. If the bases are the same, set exponents equal to each other. So that means the question mark must be equal to -3. So there it is. My question mark is equal to -3. That means this answer is -3. All right, so if we're evaluating natural log of the square root of e to the 5th power, remember there's certain things that we can do here to make this problem a little simpler. And one of them is, if things are in radical form, it's best to try to make sure we know what those exponents actually are, because logarithms, natural logs, they do state relationships between bases and exponents. So until we write it in exponent form, they can seem complicated. So remember, this is a square root sign. Remember, the square root sign lets you know that your power is a 1/2, right? So that means the 2 is going to be in the denominator, but the 5 up here is in the numerator. So what we've done was we've changed it into an exponent form. This part, by definition, you have a log with a base e. And now we have that equal to a question mark. So rewriting a problem into its correct form is key. And then from here, remember, once we have it in this format, we can go in a circular motion. E raised to the question mark is equal to e to the 5/2 power. And there's my exponent form. Remember, these bases are the same, so my question mark is equal to 5/2. My question mark is equal to 5/2. That's the solution. And here's the same problem that I did on the board. I got 2.5. Remember, its fraction form is 5/2. So that's how we're able to get 5/2. Remember, it has everything to do with its exponent. So that's pretty much all the examples I wanted to go over, because they actually don't get any more difficult than that. Remember, by definition, a natural log is a log with a base e. It's good to write that out so you can see everything. Also, if you have things that are not in exponent form, like if you have square roots and stuff like that, switch them into its exponent form. Once you have your bases and your exponents showing, the logarithms help you put that together so that you can solve. Once again, if this is your first time seeing any of my videos, you can go on YouTube, type in BJ Jeffries, that's the correct spelling. It'll populate a list something like this one. That one is me. With this picture, that's me. That's the one you can subscribe to. I do videos each day I come to work.